Why, hello, kiddos. Welcome back. And boy, do we have a toughie on our hands. Um, Here, I have a picture of Luna to get some confidence. Yep, that's Luna. She can do this in her sleep. Ha 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 ha. Anywho's, alright, this is called removable discontinuities. This corresponds to lesson 2, assignment 2. There's a couple of things going on here. We're still trying to figure out where it's continuous. And then we're gonna have to play with this idea of conjugates and what they're used for. Just as a reminder, in order for something to be continuous, there's 3 conditions. Oops, why would I start with 3? First, the exact value must exist, so f of a must exist. Second, the limit as x approaches a of f of x must exist. And finally, these 2 things are the same. So that means f of a is equal to the limit of f of x as x approaches a. Alright, we're going to have to do some algebra for this one. I'm going to erase this. These were in all the videos so far, so you don't need it. Here's our problem. It says let g of x be this piecewise function when x is greater than or equal to negative 20 and x is not negative 4. It follows this rule. For x equals negative 4, it follows this rule right here. All right. G is continuous for all x greater than negative 20. So what is the value of k? We are looking for this number right here. All right. Meaning when x is negative 4, what is k? Now we can't plug in negative 4 into this top one, right? Because when you plug in negative 4 in the denominator, you get negative 4 plus negative 4, which gives you 0. And you can't have 0 in the denominator. So what I got to do is manipulate this expression right here in order to get something where I can plug in negative 4. Okay, now you're probably looking at this and you're thinking, oh no, not only do we got to mess with a fraction, there's a radical in there as well. Yep, this is about to get real. So to simplify this right here, we're going to use this idea of conjugates. This is usually my go-to move whenever I have something with a fraction in it, and I'm not a fraction, a radical, like the square root sign. I'm trying to get rid of that square root. It basically says if you have a number and you're adding something with the square root, if you multiply it by its opposite, which we call the conjugate, it gets rid of the square root. So that's what I'm going to do right here. So if I have the square root of x plus 20 minus 4, if I want to get rid of this radical right here, I'm going to multiply it by its opposite. And that is square root of x plus 20. Instead of minus 4, I'm going to put plus 4. Over x plus 4. And again, we know if we're multiplying an expression, in order to keep it the same, if we multiply the numerator by this, we have to multiply the denominator by it as well. X plus 20 plus 4. All right, now here's the rule. If I multiply it by its conjugate, it's going to follow this pattern. So the square root is going to disappear. We're going to be left with just whatever that first term is. So I'm going to be left with x plus 20. Now it's going to be minus the second term squared. So it's going to be negative 4 squared. It's going to be minus 16. Now down here, I'm not going to multiply these out. I'm going to just leave it like this. X plus 4 times the square root of x plus 20 plus 4. Alright, I can simplify this. 20 minus 16 is just 4. So it's going to be x plus 4 over x plus 4. And I still got this. X plus 20 plus 4. Sorry. I'm going to cancel out my x plus 4s. So I'm left with 1 over the square root of x plus 20 plus 4. Now I can plug in my negative 4. I can plug in my negative 4 now. So it's going to be 1 over negative 4 plus 20 plus 4. I'm running out of space. I'm going to move it over here. It's going to be 1 over negative 4 plus 20, 16 plus 4. Square root of 16 is just 4. You'll get 1 over 8. So when you plug in negative 4, you're actually going to get 1/8.